Okay, so I want to explain a couple of customer service metrics that are important when measuring logistics customer service. So this slide you might have seen in the lecture on logistics customer service about commonly used metrics or measures. I talked about how for the supply to stock or make to stock situation where customers don't want to wait, they go and they buy the product availability is really, really important because if a product is not available, the customer is not going to wait. An example of that would be diapers or grocery or milk. If you go to a store and these things are not available, you are probably not going to place an order and wait for a week. You are probably going to head to some other store or order this online. And so the store that was out of stock now missed sales. In the other situation, in supply to order, or sometimes called make to order situation, where things are produced or at least some part of production happens after you place the order cycle time becomes really important. So let's say you go to a restaurant. It's not a fast food place, it's a regular restaurant. You order a meal and then certain processing on the meal happens. It is cooked after you place the order. If not cooked from scratch, there's some cooking that happens after you place the order. And then the order cycle time will be the time between you placing the order and you receiving your meal. This could apply to many industries. So Tesla, for example, you go online, you book your Tesla car. That's when you place the order. And when you get the delivery of the Tesla car, that's when you receive the goods. So the order cycle time would be the time between placing the order and receiving the goods. So obviously customers prefer shorter order cycle time, but depending on the situation, they may be comfortable with a few days or a few weeks in a supply to order situation, but in a supply to stock situation, they want the stuff right away. So I actually want to go over product availability because there are two metrics that students need to understand. The first one is called cycle service level, and the second one is called fill rate. And we will compute both of them given an inventory policy when we cover computing the cost of inventory, because transportation and inventory decisions are related. And so when you make a transportation decision, you want to figure out the impact on inventory costs as well as any impact on cycle service level or fill rates. So inventory moves up and down. So if I go and check my inventory level every day and then I plot it on a graph like this you see on the slide, each point represents the inventory that was available on that particular day. So you can see inventory moves up and down. Now, why does inventory move up and down? Inventory, when you receive product or you manufacture product, inventory goes up. Okay, so depending on where you're looking at the inventory, if you're looking at inventory at Kroger, when they receive a shipment via truck from their warehouse, the inventory in the Kroger goes up. So inventory always goes up when you receive stuff. Received manufactured goods, or if you're sitting inside a factory, when you finish production, your inventory goes up because now you have this bunch of goods that you've produced. Why does inventory go down? Whenever you sell something. So if you sell 10 gallons of milk in Kroger, the inventory in Kroger goes down for milk by those 10 gallons. So because sales are happening all the time and occasionally you're getting shipments of goods, inventory moves up and down over time. Now you will notice that there is a zero level on the horizontal axis, and sometimes we have inventory going below zero. How can inventory be negative? This is conceptual. Well, it can be negative if you allow back order. So what happens when you're out of stock? One of two things happens. Either the customer takes a rain check by placing an order but accepting late delivery. Now, this is not even an option at Kroger. If they're out of milk, you can't pay them for the milk today and pick up the milk tomorrow. They might allow it in some cases, but I've not seen that as an advertised policy, at least in grocery stores. Right? So in grocery stores, inventory should not be negative because they never accept an order if they're out of stock. So in a grocery store situation, the negative inventory is conceptual. For example, here on day 20 or 19, we have about minus 300. Okay, that is conceptually showing you that you had a demand for 300 product quantity when you were out of stock. So your inventory was 0, but there was a demand for 200 or 300. That was lost sales. You missed that demand because you're out of stock. And so if you add that demand in as depleting inventory, you actually went down to negative 300 because you should have had 300 inventory there to meet that demand. So that's when there's no back orders. Customer walks away, there's a lost sale. If there are back orders, that minus 300 is you have 300 units of a back order and you have to, quickly supply that. So, Land's End website, for example, if you order winter jackets from them, they allow back orders. So if they have out of stock, you can still place the order, but on the checkout screen, it will say this item is back ordered, expect delivery next month, something like that. And so, the inventory for that item, which is out of stock, is going negative and negative as people place more orders. And when they actually produce the jacket and ship it out, then that inventory will come back up. But, the back orders will get settled. The negative inventory will get settled against the new production that arrived because part of the new production will get shipped out immediately to fulfill those back orders. Okay. So in any case, negative inventory represents either back orders or lost sales. So to track our customer service metrics related to inventory, there are two things to look at. One, we can look at how often does inventory go negative or out of stock. If there's no back order allowed, how often does inventory hit 0? Or if back orders are allowed, how often does inventory go negative or 0, right? So how often are we out of stock? How often does this occur? That frequency of being out of stock is called cycle service level. Well, 1 minus that frequency. So if you are going out of stock 10% of the time, then your cycle service level is 90%. That means 90% of the time you have enough inventory, 10% of the time you're out of stock. The fill rate is different because the fill rate is what percentage of demand did we miss, or what percentage of demand went into back orders. So we add up the negative spikes. We say, okay, how much quantity did we miss in lost sales? And then we divide that by the total demand. Now, if it's not clear right now, don't worry. Let's go over an example to really see the difference between service level and fill rate. So in this example, we have 10 months of data. And we receive an inventory replenishment every month. So, the inventory cycle is about 1 month. So we have 10 inventory cycles here. Okay. Now, what is an inventory cycle? Sometimes students get confused. What's this term inventory cycle? Well, if you look at the inventory plot over time that you saw on the previous slide, you see that, every so often inventory spikes up. Okay. Why does inventory spike up? Well, because you receive a shipment of product, right? And so your inventory just jumps up. So whenever you receive a replenishment and your inventory jumps up, that marks the start of a cycle. After this jump up, inventory will start falling as you make sale. As you sell stuff, inventory starts falling. And eventually you'll get a second replenishment, inventory will jump up again. And that's the start of the second cycle. So the first cycle has ended. So each cycle is basically the time between two inventory jumps, or in other words, the time between getting a replenishment. So you get a replenishment 1, the time from that till you get replenishment 2, that's an inventory cycle. An inventory cycle is an important concept because during this cycle, you're not going to get any replenishment. The whole cycle ends and then you get the second replenishment. Right? You can actually control the cycle depending on how you send the inventory policy. So, when we talk about inventory costs, we discuss a little bit of inventory management. You'll see that Depending on how you manage inventory, you can decide if your inventory cycle is going to be 1 week, you get weekly replenishment, or monthly replenishment, or so forth, right? So if you are getting weekly replenishment, we'll do it by week, and each week will be inventory cycle. In this case, we have a monthly cycle and we have 10 cycles here. And each month we see the demand. Demand is how much product was demanded from the customer. Okay. So in month one, customers came, maybe not just one day, over the whole month. We had demand for 150 units, 150, whatever thing we are selling. If we are selling shoes, or jackets, let's say we're selling jackets, demand was for 150 jackets. And we only sold 140. Look at the sales column in month one, we only sold 140. Well, you might say, why? Why didn't we sell 150? Because we went out of stock. So we only had 140 pieces jackets in stock. So we sold 140, and then we had 10 lost sales. Okay, maybe customers walked away. They don't want to wait. It's not back orders. If this was a back order situation, we just renamed the lost sales column to back order. But then the next month, those 10 would need to be filled. So the inventory we get next month, part of that will go to fulfilling the back orders first. But here we have lost sales, right? So we had 10 lost sales in month one. And then month two, we had a demand of 115, and we were able to supply, the entire 115. Great job. We had inventory to supply the entire demand. And as you move down the months, you can see, most of the months we are okay. But 3 months we have lost sales. Month one, we had lost sales of 10. Month four, we have lost sales of 20. Month five, we have lost sales of 5. And if I add these three up, a total of 35 units of demand we could not sell because we were out of stock, right? And 3 out of the 10 months we were out of stock. Conversely, 7 out of the 10 months we were in stock, no problem. Right? So cycle service level is the probability of being in stock. So you just count how many cycles you were in stock divided by the total number of cycles. So over this time period, we were in stock for 7 cycles, 10 minus 3. Total number of cycles is 10. We divide by 10, we get 0.7. So cycle service level, we usually express probabilities as a percentage. You just multiply probability by 100 to get a percentage. So 0.7 becomes 70%. So the cycle service level is 70%. How do we interpret this number? We say there's a 70% chance that any given inventory cycle, we're not going to have stock outs, that will be in stock, 70% chance, right? Or in other words, 70% of the inventory cycles, we don't have any problem. We're in stock all the time, okay? So 70% doesn't seem very high. 30% of the time you're going out of stock. Is that bad? Well, fill rate is going to shed more light on that. Okay, fill rate is basically what percentage of demand you were able to satisfy. So I need total demand first. I have to sum up the demand column to see what is my total demand. And if I sum up the demand column, I get 1180. So my total demand over this time period was for 1180 jackets. Well, what proportion of this demand I was able to actually fulfill and make sales? Well, we can sum up the sales column, right? Or we can just take the demand number and subtract the lost sales out of it, because lost sales are the missing sales. So I take 1180 minus 35, I get 1145, which is basically the sum of the sales column. So 1145 out of the 1180 I was able to fulfill. So when I take a ratio of both, 1145 divided by 1180, I get a fill rate of 0.97, which means that 0.97 proportion of the demand I was able to fill or fulfill. That's where the word fill comes from. Fill means you supply that demand. Okay, so usually we express it as a percentage, so multiply by 100. So the fill rate turns out to be 97%. That seems pretty good, right? 97% of the demand we were able to supply. So notice that the cycle service level and fill rate can be quite different. If your stockouts are not very deep, your lost sales are 10, 20, they're not like 500, then your fill rate could still be high, 95, 98, 99%, even though your cycle service level may be 75, 80%. Okay. So we have to keep the two in mind. Getting a cycle service level to be really high, like 99%, can be very expensive. You have to keep a lot of stock. So often companies might say, well, we want the fill rate to be high. We want the fill rate to be 99%, but we are okay if the cycle service level is 90 or 85% or 80%, as long as the fill rate stays 99%. So, it depends on your situation. If you are a very high-end retailer and you don't want the item to be out of stock at all, you want to be known that, people go there, the new stuff is always in stock. Maybe you want the cycle service level to be 95, 97%. But if you are like dollar store, you don't want to carry a lot of inventory because you have very thin margins, you might be okay with a cycle service level of 70 or 75% as long as your fill rate is above 95%, right? So you have to think of both of these when you think of, the evaluating a company on availability. Thin margin companies will often be okay with a fill rate below 99%, maybe 95, 97%, because they can't afford to keep cycle service levels so high to get a fill rate very high. So it really depends on your inventory cost and how much margins you have and other trade-offs like that. But hopefully with this example, you conceptually understand what does cycle service level mean and what does fill rate mean.